Hello, good day everyone. Last time we are talking about assembling the source code. Now we continue with how to load it and execute it in the computer. The platform here is mainframe, but it shouldn't be very different with any platform. Last time, the source code, which is assembled in the last presentation, was programmed to calculate data 5 equals to data 1 time data 3 time data 6. Here is the source code. Data 5 is full word 4 byte with alignment of 4, and the other input data 1 equals minus 25 in hexadecimal will be like this. Data 2 5000, here is in hexadecimal. Data 3 is half word 2 bytes in hexadecimal 0002. Data 4 is hexadecimal 2 bytes. Data 6 is 100 in hexadecimal is 64. From this input, then this program should calculate data 6 equals to data 1 times data 3 plus data 6. The first thing to do is loading the model into the memory. Here is the model. Regardless it is a DAC or load model, but internally the format is like this in memory format. Now it must be loaded into the memory. Let's say loader decide to load to the address of 10,000 hexadecimal. The process can be illustrated like this. As it is all are in full word alignment. Done. Next is executing the module. Once it is scheduled, operating system will prepare PSW, execution control, program status word. The last word will be contained the address of the memory of which the content of that location will be executed. So once it's dispatched, PSW will point to the address of this entry point. Let's say in this case is 10,000 hexadecimal. From this address, according to memory wording, one word will be loaded into the instruction register like this. Then it is encoded like this. Take the operation code or opcode, and based on this opcode, processor will recognize the actual length of this instruction. 0D or OD got length of 2 bytes. Here the operand is C and O, C and 0. OD, 0D mean brand and save register. Brand to the address, then save. Operand should be register number. C means 12. The second operand also register number, but if you put 0 here, means not used. If it not used, then it will brand to the next sequential instruction of this instruction, means address of its plus its length. If its address is 10,000 as its length is 2, then register C will contain 10,000 plus 2. Like this. Here is the trick of the most of assembler programmer to generate base register. Then in the source code you code using instruction with a base of register 12. Next, update the PSW means drive the execution control to that location. Where is it? Here. Here is 10,000. Here is 10,002. As usual, it will load 4 byte 5810C012 into the instruction register and then encode it like this. Opcode 58 instruction register can recognize that this instruction length is 4. This instruction is to load the content of memory based on base address in register 12 at displacement of 12 into the register 1. Base register or register 12, register C, contain 10,002 plus index 0 and displacement 12. The result is 10,014 hexadecimal. Then search data from 10,014 4 byte loaded to the register 1 like this. Next, starting here, the green one, 4C10CO1A. Take it to the instruction register and then encode it here to determine its length, which operand, and so forth. 4C is multiply the content of the register 1 with half word located according base register C and this displacement. Here is base 10,002 plus this displacement. The result is 10,001C. Here, take 2 bytes. Then calculate the multiplication. The result is minus FFFFCE like this. The content of the register 1 will be replaced by this result. Next is 5A. Starting from this 5A byte, 5A10CO22, then take it into the instruction register and code like this. Determine its length and which operand. 5A is adder to add the content of register 1 with the content located according to this base register at this displacement, and then the result put into the register 1. This is the result. And then replace the content of register 1 by this result. Next, 5010CO1E. Take it into the instruction register and code it like this. This instruction is to store the data from register in operand 1 into this location according to base register and this displacement. Where is it? Here, 10,020. Here's the location, and then the content of register 1 will be copied to this location. Okay. Next, O7FE means branch according to the condition in the first operand to the address contained in the second operand. First operand must be 4-bit mask and second operand must be a register number. In this case, take it first into the instruction register and code here is on 2 byte length. It means branch to the address contained in the register E in register 14 based on the condition stated in this operand. F means all 4 bits are on, no condition. So you can say that this one is branch unconditionally to the address contained in the register 14. Here just for assumption, assuming the register 14 contain of this address. Then go to this address. Okay. As now the address of execution is changed to the content of register 14, then automatically PSW updated to point this address. Usually return to the caller. Then execution complete. Result in the register 1 in the data 5 is 32 hexadecimal or 50 decimal located in the address of 10,020. Thank you for watching. Good day.